Today we will mainly cover what you should have learned from lesson 1 and lesson 2, mainly 1.2 and 1.3, the first half of 1.3. And if we have extra time, I will try to cover the material that we have done from 2.1, which is from lesson 1 actually, 2.1, which we learned from lesson 1, and part of 2.3, which is from lesson 1 also. Okay, but the focus will primarily be from 1.2 and 1.3, the first half. Now, if you have any question, please let me know. Just interrupt me or put your drop your message through the chat. Okay.
Wait, quick question before we start.
Okay.
I enrolled after the first class session. What did we go over?
We went over the following. Let me share with you. So if this is the first day you attend the class, then I need you to go to Confer now.
Mm-hmm.
Okay, and then go to event recording. Okay, and then our first day of class was on Tuesday, right? Okay, so you go to this Tuesday, the recording on Tuesday, and you watch the recording. I think the one you need to watch is I don't think it's, is it MP4? Yeah, I think it's MP4. The file should be MP4. So you click this one, then you will see the recording of that day.
Okay.
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 Mm-hmm.
Thank you.
That's the recording from last time. Give me a second. I have chat coming in. Let's see. Which YouTube lecture should we have watched from announcement 4 before today's class? Now, today is the second meeting, right? Today is the second meeting. So from announcement 4, you need to watch lesson X before meeting number X. Today is the second meeting. So by today, I expect you to have watched lesson 2. Okay, so on Tuesday next week, before you come to class, I expect you to have watched lesson 3. And the reason I give you this in advance so that if you happen to have extra time, you can watch ahead of time. Okay, and do exercise ahead of time. Okay, that way then, if you have question during my discussion time, then you can ask that and I can help you. I can answer more question, especially the one from students instead of like I just answer question from the book on my own. Okay, so I hope that clarifies. You need to watch lesson X before meeting number X. So today is our second meeting. Then you should have watched up to lesson 2. Okay, now Thomas, why don't you just put a date there? The reason is this section I cover 2 classes, right? Yours is Tuesday, Thursday, and the other one Monday, Wednesday. So once I put a date there, then I may confuse one of the class. Either I confuse the Tuesday, Thursday one, or I confuse Monday, Wednesday one. Okay, so you are the one I would like you to keep track of which lesson you're supposed to watch. And of course, during the class time, I will also remind you, hey, you know what? Like, for example, for you, by next week, Tuesday, you should have watched lesson 3. By next week, Thursday, you should have watched lesson 4. Of course, if you can go forward on your own, go for it. But don't just go forward without doing exercise from the book. Okay? Other question maybe from here? No more? Let me do problems from 1.2. And if you have any questions you want me to go over from this 1.2, let me know. Okay, just interrupt me or drop me a message through the chat. Okay, from this 1.2, number 4. And I try to do problems for the material for your section for Tuesday, Thursday will be the same to material for Monday, Wednesday. But I try to do different problems on different days. So today, Tuesday, Thursday, I will do these problems. On Monday, which is the second meeting for Monday, Wednesday class, I will try problems different from this one here. Okay. That way, then there's no redundancy. I don't need to be redundant, and students who happen to have problems from other questions can have that answer too. Number 4, the question is to basically simplify from this 1.2 to 0 plus 0 to the 2 over 2 plus 0. Notes some important rules. As long as x is not a 0, for x not equals to 0, then x to the 0 is 1. Okay, and then 0 to the x, I think I shouldn't say that. 0 to the positive number is 0 to a positive number is 0. Okay, for example, 0 squared, you will see that's equals to 0. However, 0 to the negative number is undefined. Okay, 0 to the negative 2 is the same to 1 over 0 squared, which is 1 over 0, which is undefined. Okay, now 0 to the 0 is indeterminate. Let's call it undefined also for now. These are little notes that you need to memorize. Okay. Actually, you don't need to memorize. Like 0 squared is 0 times 0. It must be 0. 0 to the negative number means the 0 on the denominator. Okay. So this is 2 to the 0 is 1. 0 squared is 0 over 2 plus 0. That's 1/2. That's Mickey Mouse. That's number 4. Number 8. Let me do it here. Number 8. 16 to the power of negative 3/4. Now, when you do your problems, have this habit that one step should be done at one line. In other sense, that the next step should be done in the next line. Okay, so instead of going to the right, even though I will not penalize you too much for that. Instead of going to the right, the proper way to show the work is actually the next step should be done in the next line. Okay, and you will see that rules actually being followed very closely by our textbook and a lot of textbook too. Okay, now if we have negative exponent x, so the notes for this is x to the negative n is the same to 1 over x to the n, the reciprocal. Okay, and x to the power of a over b is equal to the bth root of x to the a, okay, which we can also write as the bth root of x to the power of a. Now, so going back to that question, 16 to the negative exponent, I get rid of the negative first, right? So it will be, I put it on the denominator, 16 to the power of 3/4. Okay, so this is 1 over 16 to the power of 3/4 is the same to say the 4th root of 16. After we're done with the 4th root, we take it to the power of 3. That's what the 3/4 means. 3/4 exponent. Okay, so this is 1 over the 4th root of 16 is 2 to the power of 3. That's equals to 1/8. Okay, now this number 8 is actually simple exercise, but we need to know these ideas here. Okay, That's for number 8. Number 12. Number 12. Simplify negative 3x to the negative 2 times 4x to the 4. We will just multiply that across. So coefficient times coefficient, negative 3 times negative 4 will give us negative 12, right? While x to the negative 2 times x to the power of 4 will be x squared. Okay. When we multiply the same base, x to the a times x to the b, that's equals to x to the sum of the exponent. So I added negative 2 plus 4, that's how I get that square. Okay, that's what I do there. That's for number 12. Number 18. Number 18 here. 3y cubed times 2y squared being squared over y to the 4th cube times 5y cubed to the 0. Okay. I will do this first. I basically will follow order operations. Okay, so I will do the exponent first. So I will simplify this. I will simplify this. And I will simplify this. Okay, I hope the color not confusing you. Instead, will make you realize what I did at what position. Okay, so 3y cubed, I will just copy that down. Okay, now how about the yellow part? 2y squared being squared will give us, if I have x, y, let me use blue color. If I have x, y to the power of a, that's equals to x to the a, y to the a. That's the power rule. Okay, so this will be 4. 2 squared give me 4. Y squared being squared is y to the 4. Okay, that's actually another power rule. So those are the notes. This is the first note. The second note that we learned here is x to the a to the power of b is equal to x to the product of a and b. Okay, so at the bottom we will get y to the 12. Right? That's the yellow part. That's the blue part. Now the thing is, what happened to the green one? Something to the 0 will be just 1. Right? I have that note earlier. Okay, so you will see we basically ignore it, right? Okay. Multiply by 1 will not change the value. Now then I will multiply across on the top. I'll multiply this. Okay. And then in the step after that, I will divide by y to the 12th. Okay, let me do that first. 3 times 4 gives me 12. Y cubed times y to the 4th is y to the 7th over y to the 12th. Okay, now just cancel the y's then. We can cancel 7 y's to the 7th, right? So it will be 12 over y to the 5th. That's for number 18. Number 24. We have negative 2 xy squared to the 5th times x to the 7 over 8y cubed. I will follow order operations, of course, and then it means I need to do this exponent part first. Okay, I will need to do that one first. What will that be though? Negative to the power of 5 is negative. 2 to the power of 5 is 32. X to the power of 5 is x to the 5th. Y squared to the 5 is y to the 10th. Times x to the 7 over 8y cubed. You will see that this is basically on the numerator. This is basically on the numerator, right? Okay, so you can multiply right away and then divide by 8y cubed, or you can cross cancel first if you want. Okay, and then multiply by x to the 7. Okay, now let me cross cancel first, or what should I do? Let me multiply first then. Let me multiply first. So if I multiply, I will get negative 32 x to the 12 y to the 10th over 8y cubed, and 32 divided by 8 is 4, right? So negative 4, x to the 12 stays, y to the 10 cancels, y cubed becomes y to the 7. So we have only 1 left on the denominator. I will just write it this way. Okay, that's for number 24. Let me see what's the next question. Number 30. Number 30, similarly, we'll write down the question. Number 30. Oh, wow, that's so similar. Okay, I get negative 2 r squared s to the 5th times 3r to the negative 1 s cubed squared. Now, I will show you two different ways to do this. Okay, I will show you two different ways to do this. The first way, if you think you are more mature, but just careful though. If you think you are mathematically mature, then go ahead with this. Okay, I just go ahead with taking to the power of 5th and square it. So it will be negative 32 r to the 10th x to the 5th. That's for the first factor. Okay, so the yellow one here becomes this. Okay, and then the blue part here will become what? That will becomes times 9 r to the negative 2 s to the 6. Okay, and then I multiply across. Negative 32 times 9 is what? That will be negative 288. How about the r? R to the 10th times r to the negative 2 is r to the 8th. S to the 5th times s to the 6th is s to the 11th. But you need to be a bit careful, especially if we have negative exponent on the coefficient negative 2 or coefficient 3. Okay, now that's the first method though. This is the first method. Let's see the second method. Oh, you know what? I will keep them in that color. The second method, I show you two methods not to confuse you, but to show you that in one situation, like in this case, it's actually quite straightforward. But in some other cases, you may want to be a bit careful. Like what I would do here. Oh, you know what? I think I make a miss. You know what? I copied the wrong. Do I copy the wrong question? No, no, no. I think I copied it right. I confused it with number 28. Yeah. Okay. So yeah, I copied that right. The second method is this though. I will deal with the negative exponent inside that parenthesis first. So I will rewrite it as 3s cubed over r. Okay, that's the yellow one, which I don't do anything. And I just modified the blue one. Okay, the r to the negative one, I put it at the bottom. This way I deal with only positive exponents. Now then, the yellow one becomes negative 32 r to the 10th s to the 5th times 9s to the 6th over r squared. So you see why we subtract the exponent of r earlier. The r to the 10th times r to the negative 2, right? Why it becomes r to the 8th. Now the explanation is because you have r to the 10th actually on the numerator and r squared on the denominator. Okay, so when you continue computing this, you will get negative 32 r to the 8 s to the 11, the one we had earlier above. Okay, now the second work here, the second way to do the work seems to be not really necessary, but I have seen that imagine if you have negative exponent here, instead of r to the square, you have r to the negative 2, and you have to the power negative 5 and to the power of negative 2 here. Okay, then the second method may be more useful. Okay, the second method in that case may be better. Basically, the second method will slow you down a little bit, but you will see the places where you possibly make mistakes. Okay, let's go on. After that, number 30, number 36, 40, 44, 48. Number 36, let me do it here. Number 36, 8r to the 1/3. 8r to the 1/3. And then 2r to the 1/2. Okay. Now, because I have the 1/3 outside of the parentheses, it means I'm supposed to do 8 to the power of 1/3, r to the power of 1/3, 2r to the power of 1/2. Is it right? Now, 2 to the power of 1/3, 8 to the power of 1/3 is the same to cube root of 8, which is 2. Right? So this is 2r to the 1/3 times 2r to the 1/2. Therefore, this becomes 2 times 2 gives me 4. But how about r to the 1/3 plus r to times r to the 1/2? Then we will add the exponent. Remember, if we multiply the same base, we add the exponents. Okay, the LCD is, let me drop it down a little bit. It's a side note far to the left. Far to the left here. So this is 2 over 6 plus 3 over 6. That gives us 5 over 6. Right? Okay, so this will be 4r to the 5 over 6. That's for number 36. Okay. There's nothing really new here, but we just put a couple things in the same question. That is, how do you compute rational exponent 8 to the power of 1/3? When you multiply the same base, what do you do with the exponent? You add, but the exponent now ugly, right? Okay, but even though the exponent ugly, you should still treat that person the same way. Okay, simply because your customer are ugly doesn't mean you will treat that person differently. Okay, because otherwise then you will treat me, you will discriminate against me, right? An ugly person. Okay, no. Even though that person does not fit your ideal look, okay, but you still need to do what you need to do. Okay. Number 40, basically repeating what we have done earlier. 3x to the power of 1/2 times negative 2x to the power of 5/2. I think this question is a lot easier than number 36. This will be a straightforward. We just multiply 3 times negative 2. That will give us negative 6. But then how about x to the 1/2 times x to the 5/2? That's x to the 6/2, right? Which is basically x cubed. Okay. Number 44. This one is ugly. C to the negative 4 over 81d to the 8 to the power of 3/4. How to do this one? There are so many ways to do this. By just looking at this, I see that I have 3 different ways to do this. I think, you know what? Let me take care of the negative sign first. So to get rid of this negative sign, okay, the exponent, I bring it to the bottom. Okay, let's do that one first. So this is equal to 1 over 81 c to the 4th d to the 8th all over to the power of 3/4. Now, what does the power of 3/4 mean? It means I will do the 4th root of that expression and whatever the 4th root is, I will take it to the power of 3. Okay, so the numerator still on the exponent, the denominator on the exponent becomes the radical, the index. Okay, so let me continue slightly to the right. So this will be parentheses, the 4th root of 1 is 1, the 4th root of 81 is 3, 4th root of c to the 4th is c, 4th root of d to the 8 is d squared. And then take it to the power of 3 will give me 1 over 27 c cubed d to the 6. Okay. Before I go on, let me warn you with some tricky question. Okay. Things that you need to be careful. Okay, things you need to be careful. Consider this: 2x squared to the power of 3. What is this equal to? I need you to be able to distinguish what happened to the coefficient as opposed to what happened to the exponent if you take it to the power of 3. Okay, now the effect on the coefficient 2 to the power of 3 will be 8. Okay, yet x squared to the power of 3 will becomes x to the 6. Okay, so what happened to the coefficient when you take it to the power of 3 is not the same to what happened to x squared when you take it to the power of 3. Okay, please distinguish that. Okay, please distinguish that. Be aware with this. Be aware with this. That's for number 44. Number 48. Number 48. The question is rewrite the expression using rational exponents. We have cube root of x cubed plus y squared. Okay, so what happened to this cube root? If I want to write it in rational expression. So the guy inside the house, I put it in parentheses, x cubed plus y squared. Okay, and then the cube root becomes the power of 1/3. Okay, that's the number 48. Number 52. Number 52, very similar. We have cube root of r cubed minus s cubed. That is equal to the guy inside the house. I put them in parentheses. And then the cube root becomes to the power of 1/3. Okay, but I need to give you some warning. Okay. Cube root of r cubed times s cubed is equal to rs, because basically what happened is this, the explanation why. Because r cubed s cubed to the power of 1/3, that's equals to just r cubed to the power of 1/3 and s cubed to the power of 1/3, which is rs. Okay, but this is not the case if you have addition or subtraction in between. This is not equals to r minus s. No, it's not true. Okay, it's not true. Now, why is it true for radical, true for multiplication, but not true for addition or subtraction? Because of the following. We know the property that the nth root of x times y is equal to the nth root of x times the nth root of y. Okay, the radical of product is product of radicals. However, the radical, the nth root of the sum or difference is not equals to the sum of or difference of the radical. Okay, now one classic counterexample for that is this. Square root of 25 is equal to square root of 9 plus 16, right? Okay, however, square root of 25 is 5. That's not equals to square root of 9 plus square root of 16, which is 3 plus 4, which is 7. Okay, so you cannot break them up. Okay, so only multiplication, you can separate the radicals. Okay, but for addition and subtraction, you cannot. Okay, yeah, 25 is 9 plus 16, right? Okay, but square root of 9 plus 16 is not the same. This guy here is not the same to this guy here. They are not the same. Okay, we know square root of 25 is 5, but if you split them, okay, if you split them, square root of 9 plus square root of 16, it will give you different answer. Okay, now that's one source of confusion. On the other hand, do not go on. This is not the same to r minus s. Okay, don't go that far. You need to know when to stop. Okay, just like when you go to casino, right? When you go to casino, you need to know when to stop. Okay. If I were you, I won't even go. That's for number 52, number 54, 56, and 60. Number 54. Rewrite the expression using radical 54a, 4 plus x to the power of 3 half. Oh, the 3 half only on the x, not on the 4. So this will be 4 plus 3 half, as the exponent means square root of x for the radical 4 over 2. And then you cube that, right? Okay. Now, but you can also see this way. You can also see this way. This is the same to 4 plus x times x to the power of 1 half, right? I mean, I'm talking from here. This guy, that's 3 half is 1 and 1 half, right? So I will break it this way, 1 and 1 half, invisible 1 here. Okay, now then I go on, this is equal to 4 plus x square root of x. Now distinguish that from 4 plus x to the power of 3 halves. Now again, the exponent 3 half is 1 plus 1 half, right? So I can break this down into 4 plus x to the 1 times 4 plus x to the power of 1 half. Okay, then the one with the power of 1 half, I need to change it into radical. That's square root of 4 plus x. Now, if you can skip this step here, go ahead. Okay, because you realize, oh, 3 half, it's a 1 and 1 half. So the 1 give me this part, the 1 half give me the radical. Boom. Okay. This is something you learn in Algebra 2, though. This is something you learn in Algebra 2. So at this point here, this simple step, just skip it. Okay, that's for number 54. Let's see more, 56, 66. So number 56, a similar exercise. Write the expression using radical. Part A, 64y to the 1/3. Now notice that the 1/3 only applies to y's, right? Okay, so this is 64 cube root of y. Now contrast that with contrast that as opposed to 64y quantity to the power of 1/3. Okay, because what it means here is supposed to be a cube root of 64y. Okay, so the 1/3 applies not only to y, but also to 64. But in between is multiplication, and we happen to know cube root of 64 is 4. Okay, so we can simplify that far. Okay. Number 60. I see no questions so far, so I will just keep on going. Interrupt me if you have any question. 4th root of 512. Oh, this one. We need to think this way. If you have, let's do square root first. Instead of fourth root, let's do examples from square root. Okay, suppose I have square root of 75. Okay, so I direct your attention somewhere else first. Square root of 25. The way we think will be like this. Can you find the largest factor of 75, which is a square number? And you must realize, oh, this is 25 times 3, right? 25 is a square number. Now then, it means this can be written as square root of 25, which is 5 times square root of 3. Okay? How about if we deal with, let's say, cube root of 81? Then think of a factor of 81 that is a cube number. Of course, this requires some maturity in math when you play with numbers. So it's basically your pre-algebra, algebra 1 thingy. Okay, so a factor of 20, cube numbers. 1, 8, that's 2 cube, right? 3 cube is 27. Oh, 27 times 3 give me 81. So this is 27 times 3. Okay, now cube root of 27 is 3, right? And cube root of 3 stays cube root of 3. So what does it have to do with 512 times? Now, for you to do fourth root of 512, do at the back of your mind, okay, the power of 4. So 1 to the 4 is 1, 2 to the 4 is 16, 3 to the 4 is 3 to the 4 is 81, 4 to the 4 is 256. Oh, that's actually, so this is actually 256 times 2, right? Okay, so fourth root of 256 is 4 times fourth root of 2. Okay, number 64. The square root of 64, a to the 8, b to the negative 2. The square root of 64 is 8, square root of a to the 8 is a to the 4, square root of b to the negative 2 is b to the negative 1. However, we don't want to have negative exponent in our final answer. So to make it positive exponent for that b, we bring that to the denominator. Okay? If the negative exponent on the denominator, then you bring it up to make it positive exponent. That's for number 64, 68. Let me squeeze that here. How about square root of 1 over 3x cubed y? Now, we do not want to have radical on the denominator. So let's simplify this a little bit. Okay, square root of 1 is 1. Okay, so we have that square root of 3x cubed y at the bottom. But let me break that x cubed becomes x squared times x. Now the reason is so that I can bring the square root of x out. Let me do that. So I have 1 over x times square root of 3xy. Now then from here we think, okay, I need to rationalize the denominator. We are not supposed to have radical on the denominator. We are not supposed to have negative exponent. Okay, so how to get rid of that radical on the denominator? If there's only one factor on the denominator, then multiply it by itself. On the top and the bottom. This way you basically square the square root. Okay, this way you basically square the square root. On the top, then I have square root of 3xy. At the bottom, I have x times 3xy without radical. Well, because of radical blah times radical blah equals to blah, as long as the blah is positive. Okay, so I use that property here. And the last step is basically this cosmetic part. I multiply x by 3xy. That's 3x squared y on the bottom. Okay, that's for number 68, 70, and 74. Number 70. The fifth root. Okay. The fifth root of 3x to the 11th y cubed over 9x squared. Let me simplify inside the radical first. So that is the fifth root of x to the 9th y cubed over 3. Now, I will break up that x to the 9th becomes x to the 5th times x to the 4th. So that x to the 5th can get out from that 5th root, right? Y cubed, the exponent is already less than 5, so it seems like we cannot do anything. And I have 3 at the bottom. Right? So this will become x times 5th root of x to the 4th y cubed over 5th root of 3. Now, notice that we have radical on the denominator. Oh, I'm supposed to do number 70, not 74. But anyway, just go on. We have radical on the denominator. I need to get rid of the 5th root of 3. I need 4 more 3's in the 5th root. Right? So I multiply that on the top and the bottom. Now notice that what's the reason you do that, Thomas? The 5th root of 3 times 5th root of 3 to the 4 give me 5th root of 3 to the 5th, which is 3. That's how I rationalize the denominator. That's why I multiply by that 5th root of 3 to the 4. Okay, so then we end up with on the top I get x times 5th root of 3 to the 4th is 81, x to the 4th y cubed inside that y cubed, okay, over 3. Okay, I think I'm supposed to do number 70 first. Let me do number 70 here. 70. We're supposed to do this one first better. So cube root of 3x squared y to the 5th over 4x. This is cube root of 3x y to the 5th, and let me split it up rather, y cubed y squared over 4. Okay, and that will be on the top, I get y times cube root of 3x y squared inside the cube root over cube root of 4. Now, but 4 is 2 squared, right? 4 is 2 squared. That's 2 squared. I just need another cube root of 2 to make it cube root of 8. Okay, so cube root of 8 at the bottom will be 2. So on the top, I get y cube root of 2 times 3, that's 6x y squared. Now, the one number 70 and number 74 requires quite detailed way of writing. So when you write, okay, when you write, for example, like cube root of 3x squared y to the 5th, don't just write it this way. This is not the same to cube root of 3x squared y to the 5th like this. No, no. I will penalize you at least half point because your roof is not covering all the way to where it's supposed to. Okay, and trust me, if you are not disciplined in your writing, it's just about time that in the next step you will make mistake. Okay, square root of 3x squared y to the 5th is not the same to square root of 3x squared y to the 5th. These are not the same. Okay, why? Because on the first one here, the square root only applies to 3, not to the x squared, not to the y to the 5th. Okay, so be aware with this. Be aware with this. Okay, these are not same expression, and therefore, when you write it, be very careful. Okay, basically, if the radical should cover up to y to the 5th, then go all the way to y to the 5th. Let me call that 1. Okay, that's for this section. Let's go on to 1.3a. On Tuesday, we will continue with 1.3b and 1.4, whatever you see on lesson 3. Okay, whatever you see on lesson 3 in announcement 4, those are the sections I will go over on Tuesday. Okay, 1.3a. This section is a bit harder because it deals with more algebra put together. In algebra 2, this one section here actually covers one chapter. What we do in one section here actually covers, actually no, not one chapter, it's actually 2 chapters put together. But let's see. Hopefully by reviewing them, then it reduces your anxiety. Okay, number 4. Expressed as a polynomial, 6x squared yz cubed minus xy squared z all over xyz. The way to do this, if you have polynomial divided by a monomial, then you split them. 6x squared yz cubed over xyz minus xy squared z over xyz. So you split them and then you simplify each term. From the first term, for example, the 6 days, x squared divided by x is x. The y cancels. Z cubed over c is z squared minus the second term. Everything cancel except the y's, huh? Y squared over y is y. Okay, not too hard, right? I think that one is quite easy. Number 8. Let me partition. Number 8. 5x minus 4y squared. Basically, you need to remember some special product. The one that is being used here is what if we have the sum being squared, a plus b being squared. When you FOIL that, you should memorize this though, okay? You should know how we get this, but then it's to the point that you need to memorize this. Okay, this is the reasoning. Okay, this is a squared plus ab plus ab plus b squared. That's equals to a squared plus 2ab plus b squared. Now, since you are already in pre-calculus, then I expect you to be able to come from here directly to here. And if somebody then asks you why it looks like that, then you explain, oh, the reason is this. But I do expect you to just go directly to that. Okay, now, and you will see that it is still true even if you have a minus b. A minus b squared will be a squared minus 2ab plus b squared. Now, how do we apply that into this question? Okay, a minus b being squared is a squared. You know what? Let me write it that way first. A squared minus 2ab plus b squared. Then we simplify. This is 25x squared minus 40xy plus 16y squared. Another special product that you have to remember is the difference of squares. Okay, a plus b times a minus b. So exactly the same terms except that the middle sign are opposite operations. Now, if you FOIL this, you will end up with a squared minus b squared. But if somebody ever asks you why, so I do expect you when you see this, you get that right away. Okay, but the reasoning behind it is if you FOIL a squared minus ab plus ab plus b minus b squared, you see that the middle two terms actually cancels. Okay, that answers really fast. For example, number 6. Yeah, I don't need to do number 6 actually, but if we see number 6, we do it quickly. 5x plus 3y times 5x minus 3y. And that will be blah squared minus blah squared. Right? And if you can skip this step, just go ahead to 25x squared minus 9y squared. That's fine. Okay. I just show you the work in the middle here. Okay. Why we get 25x squared minus 9y squared? Well, because when I do difference of squares, that fits the pattern of difference of squares. Okay. So when I write it as difference of square and simplify, that's what it looks like. Number 10. Number 10. Square root of x plus square root of y being squared times square root of x minus square root of y being squared. Now we start getting into questions in which the way you do stuff depends on your maturity level. So yes, there are a lot of ways to do a problem though, okay? And then some students I know will get mad with me, Thomas, I did it right. What's wrong with my way? Nothing wrong with your way except that you take too much time, okay? In my quiz, which is a take-home, of course, you don't have that much time restriction, but in your test, then if you use long way, it will take you too much. So for example, in this question here, suppose you do it with a long way, then very likely you will FOIL this, then you FOIL this. Okay, very likely that's what you do. Okay, if that's what you do, what will happen? Then the first term will be blah squared plus 2 blah blah plus blah squared. And then the second factor, you will have blah squared minus 2 blah blah plus blah squared. And then you see this, oh shoot, what is this? Then you end up foiling them. X squared minus 2x square root of xy plus xy. So I basically FOIL this x to this guy and then to that guy. That's what I get. Okay, and next I will distribute this 2 square root of xy to x to that to that. Okay, that's what I plan to do. Okay, so the next three terms will be plus 2x square root of xy minus 4xy plus 2y square root of xy. And then the last distribution, I distribute the y's. That will give me plus xy minus 2y square root of xy plus y squared. And then we combine like terms, x squared is there. Okay, so we are done with this. How about this guy? This guy cancels with this guy, I believe. Right? In fact, you will see that this guy cancels with this as well. Right? Okay, so I have this guy minus 4xy plus xy will be minus 2xy plus y squared. That's the final answer. And then you are so proud of you. Say, oh, I'm working hard. Well, you may work hard, but if you don't work smart, okay, if you don't think about it further, then you will think you're okay. But I don't think that's the way you want to do it. Okay. Another way to approach this problem is you see it this way. So I break this squared here, I rewrite it this way. Okay, and this square here, I rewrite it this way. Okay, what's the purpose, Thomas? what I will do next is this. Notice that this guy and this guy give me difference of squares, right? In fact, this will give me the same difference of squares. Do you see that? Okay. So we can actually write it this way then. This is basically the same to square root of x plus square root of y times square root of x minus square root of y, all of them being squared. Do you think so? Right? Okay. You can actually just come directly from here to here. Okay. The one I write above, the one I write here, just to let you see what the details are. Okay. But why you want to write it that way, Thomas? Because I want to take advantage of the fact that the guy inside the bracket here actually forms difference of squares. Okay. The thing is, difference of squares together with the so many squares there, we hope, we cross our fingers, something cancels, right? Okay. And in fact, you will get square root of x being squared is x minus square root of y being squared is y. Boom. And oh, we remember this. This is x squared minus 2xy plus y squared. Okay, now we get the same answer. We get the same answer. Okay, now you may be proud that, you know what, I work it, I do it harder and longer. Okay, and the way you did it way too simple, it doesn't show that you are smart. Nah, no, I don't think so. I don't think so, because in actuality, in the test, the second method is a lot more effective and efficient. Okay, effective and efficient. This method here, when you see this, it scares you, right? It scares me too, because you remember when I did it, I need to be extra careful not to miss anything, not to miswrite anything. Okay, anything I miswrite here will lead me to wrong answer. Okay, nothing can go wrong. And that's quite dangerous when you do math that way. So sometimes when you see a bit complicated problem, ask yourself first, is there any pattern? Okay, if you see some pattern, then try to chase that. If you don't see pattern, then you need to be patient. Okay, that's for number 10, with two different ways to solve the problem. Next one, I think it's number 12. Number 12, what happened then if we have the power of 3? X plus 3y cubed. Is there any pattern for this? There's actually a pattern for that, but you will see that maybe the last day of class or the second to the second day from the last day. Okay, so instead of waiting that much, just do it with what we know first. Okay, how will we approach this? To the power of 3, we don't have the formula for that. We have formula for square, right? So let's break it up into x plus y times x plus y squared. So I basically break this 3 into the power of 1, the power of 2. Okay, now why do you do that, Thomas? Well, because I know how to expand these. I memorize that. What if I don't memorize it? Then it will slow you down even further. Okay, not only slow you down even further, it slows you down tremendously, significantly further. There's a chance that you don't even know how to approach this problem. Okay, but if you memorize that, then this is your option. Okay, at least the first term is to the power of 1. Let me leave it like that for now. The first factor. The second factor is squared, and I memorized that's blah squared plus 2 blah blah plus Blay square. Like if you can skip this step, go ahead. And get this. X plus 3y equals to x squared plus 6xy plus 9y squared. Okay, so if you can skip from here to here right away, go for it. But I don't think you want to skip this part, the rewriting part. Don't skip the rewriting part. Okay, don't skip the rewriting part. You can skip this one. Okay to skip. But don't skip the rewriting part. I mean, you can try, but I don't think it will work. Put it this way. The most effective method is not the one with the shorter, the shorter steps, no. But the one let you finish the question the fastest. So you may write a lot, but if you can do those steps really fast, do it. Instead of you write only 2 or 3 steps, right? But then for each step takes you forever. Okay, I hope that explains why we prefer to go on freeway, because why? Freeway is actually always longer compared to local. But why we like freeway? Even though it's longer, we can drive faster, right? Instead of like local, you have a lot of stop signs, right? For example. Okay. So the nature of trying to do it fast, actually in line to what I'm trying to teach you. You try to do it fast. You are not trying to do it with the shortest steps. Okay, so if somebody asks you what is the, how do we know this method is better compared to the other method? Which method will allow you to finish the question faster? Okay, now doesn't mean you don't learn other method. Okay, doesn't mean you don't learn other method. We learn other method in case there's some kind of variation to the problem. Okay, now, but once we are done here, then we go on foiling it further. There's no specific pattern here, so I have to do it. I have to foil that long way, basically. Okay, so I will foil this x, distribute this x to x squared, 6xy, 9y squared, and then after that, I will foil this 3y to x squared, to this guy, to that guy. Basically, I do the foil. Now, let's put it to detail. I get x cubed plus 6x squared y plus 9xy squared plus 3x squared y plus 18xy squared plus 27y cubed. Now combine like terms. This guy by itself, this guy together with this give me plus 9x squared y. This guy together with this give me 27 xy squared, and finally 27y cubed. Okay, so if I redo this work, basically the idea is the following. I have something ugly to the power of 3. What I do is like 2 terms, right? What I do is I break it into a plus b times a plus b squared. Now the reason is because I know I can process this from my memory. Okay, so a plus b times a squared plus 2ab plus b squared. Then from there, I FOIL that. Then combine like terms. That's what I actually did there. Okay, I just execute that plan in a more complicated terms. Instead of just A and B, we have more complicated situation. Okay, that's for number 12. Now let's go on with the factoring. Let's go on with the factoring. Number 14. Factor 7x squared plus 10x minus 8. When it comes to factoring, always keep in mind that you always try to factor common factor first. In fact, let me emphasize this. 5 level of factorization. 5 levels. It's not only different types. It's to the point of 5 levels of factorization, of factoring. In other words, when you do factorization, always do it in this order. The first one, greatest common factor. If you have common factor, always do that. Okay. Second, factorization by grouping. Usually 4 terms. But maybe 6, maybe 8, maybe 9 terms. Is this the homework he gave us on the YouTube video? I don't remember. I usually give you suggested homework for odd numbers only, but I mean, it could be including, could be including even numbers. That's fine. Yeah, just for practice, not to turn in. You're right. Okay. Suggested homework is not for you to turn in. You don't need to turn in. It's for you to practice only. And then after you practice that, if you have questions, you can ask me. Okay. And then the third level is trinomial with leading coefficient 1. And then level 4, trinomial with leading coefficient not equal 1. And that's the case we have here. The last level is special factoring. Which consists of difference of squares, like a squared minus b squared style. Okay, perfect square, the one that gives us a plus or minus b being squared, and sum or difference of cubes. Okay, a cube plus or minus b cube. Okay, make sure you know these 5 levels of factorings, which is basically what I will do here. Okay, now in this case, it's trinomial with leading coefficient not 1. So you know, among all factoring, this is actually the hardest one. How will we do this? Well, the good thing with that 7 is it's a prime number. Okay, so there's only one way. If it is factorable, there's only one way to break that 7. Must be 7x and x, no other way. And then because the sign here is minus, it must be different sign here. Let me put plus minus for now. It may be that I need to flip that later on. I may need to switch that later on. For the 8, it's either 1 times 8 or 8 times 1, 2 times 4 or 4 times 2. Now, this is the way I taught my Algebra 1 and Algebra 2 for factoring. Now, if you learn it different way and you are comfortable with that, then you can continue using your method. Okay. I don't teach you factoring anymore unless you come to me during my office hour to ask me, Thomas, how to do this type of question, how to do that type of question. Okay. But I assume you know that because that's the job of your Algebra 1 and Algebra 2 teacher. You have done this twice in 2 different classes before pre-calculus. Okay. But if you want me to go over that, okay, I don't mind, but you need to come to my office hour. Okay, now what I did here, I basically create a multiple choice question and I will try one by one. That's what I actually doing. Okay, you like multiple choice question, right? Which is actually not a good idea, because if you're almost right, it is still wrong. That's multiple choice. So no, don't ask me for a multiple choice question. Now, when I try one by one, I found out that 2 here, 4 here will give me negative 14 plus 4, which is negative 10x, right? But what I need is positive 10. That's the thing. I need positive 10x. How to change that negative 10x become positive 10x? If you just need to change the sign, what you can do is you switch the sign. So you change, this becomes minus, this becomes plus. That will do now. Positive 14 minus 4 give you positive 10. Okay? Now, but do not use grouping method. At least if you really want to use grouping method, do it on your scratch paper. Okay? In my class for factoring, I expect to come from here to here right away. You don't need to show me the work. Okay? Last semester and in the summer, I got students cheating using photomath because of this method. Okay, because photomath, they can, for some strange reason, photomath try to explain too many things. And when it tried to explain factoring of trinomial, it always use grouping. And the way it, basically like this, factorization is one way I got students cheating from photomath. Photomath, that's an app that you can take pictures of the question and it will suddenly just show you the work. Okay, now the thing is, the way it shows the work is not natural. It follows certain procedure that they already pre-decide, such that if you have special case, photomath cannot handle that well. Okay, it tends to make things more complicated, including when it comes to factoring. Okay, so instead of relying on photomath, which you may be able to pass my test one if you rely on photomath, but you cannot run too far. You end up thinking that you are wasting your time with me, but actually, no, you are wasting your own time. You know you are not learning it. You just try to pass this class without learning anything. Okay, and then later on you want to get your degree without learning anything. There's only so far you can cheat the system. Okay, I can pass you here just so that you say, oh, Thomas is a nice teacher, but I will never be a good teacher for that. Okay, and then when you get your degree in, let's say, civil engineering, but you can never build any building. Why? Because you cheat your degree. Right? What for? What for? I mean, you can be so proud with your degree, but still unemployed, which is quite terrible. I mean, I'm not saying that if you're unemployed, that's bad. I mean, it happens, right? Okay, but that's not what the reason we come to school, so that we can avoid that, right? Okay, especially during this pandemic, being unemployed is very common. Okay, I understand that one. But if you tell me, Thomas, I have my degree, but my friends already get their job and I don't get the job, then it's like, well, okay, did you study well in your, when you did your bachelor, you know? Okay. In other words, if you cannot get a job, let it be because of something outside of yourself. Okay, because of the pandemic maybe, or some family situation that it doesn't fit your time. Okay, don't let it be because your degree is not comparable to your specification, your qualification. Okay, please learn it the right way. Don't try to cheat your way out. There's only so far you can cheat your way. That's number 14, number 18. I'm saying this for you though, not for me. Okay, you know that I'm teaching this class, I get paid regardless you pass or not. So I can just pass you and I still get paid. Or I can just fail you, I still get paid. But that's not the reason I become a teacher. No, the reason is I want to make you a better person, be even more successful than me. Okay? And there are a lot of people out there more successful than me. Okay? I want you to make you one of them. Now, number 18, 9x squared plus 24x plus 16. If you see a trinomial where the first term and the last term happen to be a square number, so if the first term and the last term happens to be a square number, then be suspicious that it may be the perfect square case. So that's what you check first. Okay, I will check the perfect square case. Now, how do we check that, Thomas? We check it this way. Okay, look at the base for 9x squared. It comes from 3x being squared, right? And the base for 16 is 4. That's why if the first term and the last term are perfect square, are square numbers or square expression, you do this first. Now, how do we check? You check this way. Get the product of 3x and 4 and double down. See if it match with the middle term. See if it match with the middle term. 2 times 3x times 4, does it give you 24? If it does, then it is a perfect square case. And this becomes 3x plus 4 squared. Why is it like that, Thomas? Well, because perfect square has that pattern. A plus b being squared is equal to a squared plus 2ab plus b squared. So if the base is a and the base is b for the first and the third term, then the middle term must be twice the product of those bases. Twice the product of A and B. Okay, so what I did there, actually I checked, oh, this is A squared. This is the A. This is B squared. This is the B. Now then I want to check if the middle term actually fits 2AB, 2AB. If it fits, then it is a perfect square. Oh, hold on, Thomas. Hold on. How do we know it's a plus here? Oh, it's plus following this sign. If it fits all the pattern, then the plus sign there follow this. So if this were negative 24x, that would be 3x minus 4 being squared. Okay, that's for perfect square. Now, it's actually a tricky type of question when it comes to perfect square, because we can actually factor this using regular way, a trinomial method. But the problem, it will take you some time. You may think, oh, it's either 3x times 3x or 9x times x. Because the sign here is plus, then it must be the same sign. And because plus plus, it must be both plus. But then how do we decide what's the pair here? It's either 1 times 16 or 16 times 1, 2 times 8 or 8 times 2, or 4 times 4. You see, I need to try one by one, right? If I do it long way. and it will take you forever. So every time you see that the first term and the last term in a trinomial to be perfect, to be a squared expression, you check this perfect square case first. Okay, that's for number 18. Number 22. Number 22. X to the 6 minus 27y cubed. Now, this is a case of difference of cube. I will rewrite it as difference of cube first. Okay, x squared being cubed minus 3y being cubed. Now, let's remind ourselves with the pattern for sum and difference of cubes. Okay, let me write it here. A cubed plus b cubed is equal to, the first sign is the same. Maybe I write it this way. Maybe I write it this way. Let's look at the sign first. The first factor has 2 terms. The second factors have 3 terms. Okay, the sign will be, in the first factor, the sign will be the same with the sign there. Same. The 3 terms in the second factor has 2 signs. Then the first one is opposite here. And the last term always have positive sign. Always positive. Somebody create a mnemonic soap. Same, opposite, always positive. Soap. Same, opposite, always positive. Now, how about the terms, Thomas? Okay, if this is a cubed plus b cubed, then the first factor will be a plus b. I use color. Okay, the second factor will be a squared minus a b plus b squared. Okay, that's the pattern. That's the pattern. That's the pattern. So this is my a, this is my b, this is my a, b. If that were a minus here, so the first sign will be the same, the second sign will be opposite, and the last sign always positive. Okay, now I know there's a big chance that you don't memorize this yet. Okay, but therefore, please memorize that. Okay, it's not something that natural as perfect square or difference of squares. A lot of instructors actually avoid this type of factoring. Unfortunately, in pre-calculus, you have to memorize that though. Okay, so if you see a formula that you think you don't memorize, write it on a flashcard. It doesn't have to be flashcard you buy from Staples or Office Depot. No, you can just write it on the piece of paper, write it many times, and then you put it everywhere at your home. On your dining table, in your kitchen, in your restroom, next to your bed. Okay, or maybe on your dashboard if you need to drive. Okay. Okay, since you see that very often, you will eventually memorize that. Okay, and of course you need to practice also though. Now let's go on here. So this is the way I usually teach, but of course you adjust with your style. Okay, this is difference of cubes, so it will be 2 factors, 3 factors. The first sign will be the same, the second sign will be opposite, and the last sign will be always positive. Okay, and then it will be blah minus blah, blah squared plus blah blah plus blah squared. Now I will put details into this. My blah is x squared, my blah is 3y. X squared 3y, 3y. Now then simplify, I get x squared minus 3y times x to the 4 plus 3x squared y plus 9y squared. Okay, so we mainly remind ourselves about difference of cubes in this question for number 22. Number 26, I will finish the factoring part for this section and then I give ourselves a break. So number 26, 5x cubed plus 10x squared minus 20x minus 40. Okay, remember, always check for common factor, and we have common factor here. But Thomas, hold on. But there are 4 terms here, so should I suspect this is factorization by grouping? Yes, but according to the order here, which one should we do first if we can do common factor and grouping? According to this guidance, that if you have common factor, do common factor first. Okay, in fact, that's always the first thing you check. Okay, do I have common factor? I have common factor 5, then take that guy out. Take 5 out, I get x cubed plus 2x squared minus 4x minus 8. Do common factor first, okay, if any. Now then, after this, no more common factor. Okay, then inside the parentheses, there are 4 terms. Okay, I suspect that's factorization by grouping. Not always true, but most of the time that's the case, just like in this one. Now, factorization by grouping is always done in 2 steps. Factorization by grouping is always done in 2 steps. That's the only factorization type that requires us to do it in 2 steps. Okay, why we call it factorization by grouping? Because we group them into two halves. So I will keep that 5, and then inside that parenthesis, the first 2 terms, the common factor is x squared. The last 2 terms, the common factor is 4. But because you have negative here, I will factor the negative also. Okay, minus 4 times x plus 2. That's the first step. That's the first step of 2 steps in factorization by grouping. Okay, you break it into 2 halves. The first two terms, you have common factor. The last 2 terms, you have common factor. And the second reason why we call this factorization by grouping, because it turns out they still have common factor, but the common factor here is a group. So I keep that 5 already outside. Okay, and then the common factor as a group is x plus 2. Okay, then the remaining x squared minus 4 will become our last factor. Okay, so I usually, if I teach algebra 1, I usually put this notation. What I did here is actually level 1. Factorization, greatest common factor. And then what I did here is level 2. Factorization by grouping, it takes 2 steps. And it turns out that x squared minus 4 is still difference of squares. That is level 5a. X squared minus 4 is x plus 2, x minus 2. Now we usually summarize that as 5 times x plus 2 squared, x minus 2. Okay, that's for number 26. The last question before the break, number 30. We have x squared minus 4y squared minus 6x plus 9. Ooh, this is nasty. There's no common factor. In fact, even if I try to do the grouping like this, even when I try to do grouping like this, there's no common factor here. We have common factor 3 here. So factorization by grouping this way doesn't work. Okay, doesn't work. But I hope you notice that this guy here, together with this guy and this guy, give me a perfect square. X squared minus 6x plus 9 minus 4y squared. I reordered them first, and then I want to show you that this is actually perfect square. X minus 3 being squared. Okay, and 4y squared is also a perfect square, right? Do you see that now? Okay, so this is another type of factorization by grouping, but the breakdown is not two halves. No, no, no. It's not the first two terms, the last two terms. No, no, no. You happen to see, that's why it takes some maturity. You happen to see, oh, you know what? This guy, the blue one, actually form a perfect square. So let me put them together, and after I rewrite them, oh, they are actually difference of squares. So it will be x minus 3 plus 2y times x minus 3 minus 2y. Okay, that's for factoring. Now let's take our break. Right now is 9:44. We take.
Hi, everybody. As Thomas said, my name is Malachi, and I'm the SI leader for this class, and also the other section that he's teaching this semester. So basically, my job is I'm going to be sitting in class with you guys and seeing exactly how Thomas is teaching you all the material. And then I'm going to have my own separate sessions where I go over some extra material that I prepare, just to help you guys spend a little bit more time with the math and hopefully get to understand it a little better. It's going to be kind of like a group study kind of thing, where I give you guys different problems, maybe some old exams, and we go through them together and kind of discuss the way things are the way they are. So yeah, feel free to attend those sessions. It's going to be two normal sessions where I prepare material, and one drop-in session where you can just come in and ask me whatever you want every week. So I'm going to put my email in the chat right now. If you have any questions for me about this. So next week, I will be back here with a survey that will ask you what time you're free for me to hold the sessions. So between now and next Tuesday, think about what time you'd be willing to go to an extra group study session, what time you're free. And I will also be back next week with the Discord server that I'm currently setting up. So yeah, there's my email right there. If you have any questions about my sessions or even math, I can try and help you out. So all right, thank you, everybody.
Okay, thank you, Malaki. And because Mr. Maldonado, Malaki, had been with me for 1 year, you may want to ask him what kind of instructor I am. Okay, he knows me, my teaching style and my grading style. And sometimes when students complain, they complain to me, complain to him first before he pass it to me. Okay, so you can go to him, you can come to me, either way, or both will be even better. Okay, but try to benefit from what the campus provide us. You know, the campus pay him a lot on the top of paying me a lot to help you with this class. So, okay. Oh, by the way, Malaki.
Yeah.
Still, do they approve you to have both of my session already, or
Yes.
only one?
Yeah.
Oh, great. So I hope you get the double one.
Oh, I know.
Yeah, and you don't need to attend both actually. You just need to attend one of them. In fact,
Yeah,
you
so
you know
gonna
me
attend-
already, so
yeah.
I don't even need you to attend. Yeah, just make sure you have time for my students.
Okay.
Okay. Yeah. Thank you very much. I really appreciate it, though.
All right.
Okay.
Thank you, everybody.
Okay. Then going back to 1.3a. Am I recording this? Yeah. 1.3. Continue with the rational expression. I did up to number 30 already. 32, 34, 40, 44. 30, 34. Is it 34? I can't remember. Yeah. 40, 44. Number 30. Look. Number 32. That should be number 32. Number 32. Okay, simplify the expression 12 plus r minus r squared big over r cubed plus 3r squared. Now, when it comes to rational expression, we assume you know how to do factoring well. Okay, now the top one is trinomial. Some students, they don't get used to factor in that reverse order, and that's okay. That's totally fine. I mean, I didn't get used to it either. Okay, so one way to do it is to change the order first. In descending order, we say. Okay, and if you get trouble with that negative, factor that out first. Okay, so I will factor the negative out from the top. And then at the bottom, oh, I have common factor r squared at the bottom. Okay, that's nice. Then inside that grouping on the numerator, you factorize further. That's trinomial, right? So this is negative r minus 4, r plus 3 over r squared, r plus 3. Oh, r plus 3 is the common factor, so I can cancel that. I end up with negative of r minus 4 over r squared. Now notice I put my negative right in the middle. Right in the middle. Okay. It is not the same. Negative r minus 4 over r squared is not the same expression to negative r minus 4 over r squared. Okay, no, they are not the same. Okay, but you know what, Thomas? I know that they are not the same if this line is longer, but if it is that shorter, they should be the same. No, because your negative sign refers to only r. So there could be some multiple interpretation for what you wrote on the right-hand side here. Okay, because of that possible multiple interpretation, then I don't want to say that they're the same. Okay? No. In fact, the one on the right-hand side may be understood as negative of r plus 4 over r squared. Okay? That's one. That's one. In case you think you can factor it directly on the top, so instead of doing it that way, you say, you know what, Thomas, I think I can factor it right away. I just factor it backward. So the bottom's still the same, r squared times r plus 3. Yet on the top, I know it must be plus r minus r. So you do it from the back, right? Okay, what times what is 12, but the difference is 1. That's 4 and 3. So 4 minus r, 3 plus r. You can check. This is negative 3r plus 4r, right? Now then you realize, oh, you know what? 3 plus r is the same to r plus 3. So I can cancel them, and I end up with this. Okay, now these two are legitimate answers. This is okay. This one is also okay. But they look different, Thomas. Well, look different doesn't mean they're different. Okay, what is the explanation? Because of the following. If you subtract in reverse order, you get opposite sign. Okay, basically I'm saying that 4 minus r is the opposite of if you reverse the order of subtraction. Okay, that's what happened there. And that's actually not something new though. That's very natural. That's the way we did subtraction with negative number, right? For example, if you need to subtract, let's say 5 minus 12, okay? We know that's negative 7. We know that's negative 7. But if you play the movie a lot slower in your mind, how did you get that negative 7? The way you think is like 5 minus 12. Oh, 5 is smaller than 12. Then it must be negative. How did you get that 7? You actually subtract 12 minus 5. Right? Okay. So what I did above here is just the abstraction of the procedure was done way in pre-algebra. Okay, that's not something new. If we reverse the order of subtraction, we get the opposite of that expression. Okay, so what do I actually teach you in this number 32? Two things. First one, what happened if the trinomial not in descending order? One way you can do it, you reorder that first into descending order. And because of that negative, you factor that negative out, and then from there you go on as usual. Okay. Now, however, if you think you can advance a little bit, do variation in factorization of trinomial, then consider thinking of this way. Okay. The idea is still the same though. Negative r squared on the last term, so it must be plus r minus r, no other way. Okay. Oh, yeah. That reminds me of something. Even though when we reverse the order of subtraction, we get the opposite, but when we reverse the order of addition, we don't get the opposite. When we reverse the order of addition, okay, a plus b is equal to b plus a. Okay, a plus b is equal to b plus a. A minus b is the opposite of b minus a. What do you call this, by the way? Anybody remember? You call that commutative property. Okay, that's commutative property. Now, multiplication and addition has commutative property, not with subtraction. Not with subtraction. Okay, that's for number 32. Let me go on number 34. Number 34, 5a squared plus 12a plus 4 over a to the 4th minus 16 divided by 25a squared plus 20a plus 4 big over a squared minus 2a. Now, in this one question, we will have a lot of factoring and diffusion of rational expression. If you ask me how I will do it, I try to break it down into simpler steps. And if I will do it the same way, even if I do it for myself. Okay? In other words, if I'm preparing for this question at home and I want to see myself what's the answer, I tend to do it this way. Okay, I will not do factoring right away. I will flip the divisor first. Change that into multiplying by the reciprocal. Do you remember that? Dividing a fraction is the same to multiply by the reciprocal. Okay, that's why now it becomes multiplication instead of division. Now, then the next step, I will do factoring. Okay, when it comes to factoring, I need you to practice such that each factorization can be done in less than 1 minute. Otherwise, this question will take you too long. If it takes you like 2 minutes for each, then this question may take 10 minutes. But that's way too long. That's way too long. That's way too long. Okay? It should take you less than 1 minute for each type of factoring. In fact, like for example, this guy here and this guy here and this guy here should take you less than 40 seconds. When you practice, you don't need to practice like you look at the time all the time, okay? But have some feeling, you know what, it takes me too long. I need to practice more. I need to practice more. And feel free to go online and you Google practice factorization. Okay, in case you can get some handout from other teachers online that give you practice for factorization. Okay, but I don't forgive any students who cannot do factorization after I'm done with this section. Okay, you need to practice, you need to know it. Okay, if you need to learn something, you have questions, come to my office hour. Okay, there I will help you, but I will not spend our class time, our valuable class time for something that your previous 2 instructors supposed to have taught you. Okay, no. Now then we do factoring here. 5a squared, no other way, it must be 5a and a. That's plus 4, the same sign, both of them plus. 4 is 2 and 2, no other way. A to the 4th minus 16, that's difference of squares. That's a squared plus 4 times a squared minus 4. Oh, I can factor that further. I do it later. So on the top right, this is common factor a. And the bottom right, we have 25a squared. Let me do the scratch work here. I'm just trying to show you. You see 25a squared is perfect. It's a square expression, right? And 4 also square expression. The product is 10a. Don't forget to double down. Yes, it matched. Okay, that's a perfect square. So this will be 5a plus 2 being squared. Okay, let me factor this further. You can just erase that and change it, or you rewrite it again. Let me just rewrite it. So I have a squared plus 4, a plus 2, a minus 2 times a times a minus 2 over 5a plus 2 squared. Now then, let's do canceling. We have 5a plus 2. I can cancel one of them. A minus 2 I can cancel. I'm sorry, a plus 2, and then a minus 2 I can cancel. So I have at the end on the numerator only a, and then on the denominator I have a squared plus 4 times 5a plus 2. This one question requires you to know how to factor trinomial with leading coefficient not 1, to factor difference of squares, in fact twice, to do common factor on the top right, and then perfect square on the bottom right of the one here after I flip it. That's number 34. Number 40. T over t plus 3 plus 4t over t minus 3 minus 18 over t squared minus 9. How do we simplify this? Get the LCD first. Notice that this guy here is t plus 3, t minus 3, right? So the LCD is t plus 3, t minus 3. Let me prepare the space first and put the LCD. Now then on the numerator, I already have t on the first rational expression. Okay, but you see that t over t plus 3, that's what we have, right? This t minus 3 is the newcomer on the denominator. To keep it equivalent fraction, then I need to multiply the top by t minus 3. Okay, basically, at the bottom, I multiply by t minus 3. So on the top, I multiply by the same expression to keep it equivalent fraction. Oh, Thomas, why do we need to do that? Well, because even in pre-algebra, that's what we did. Okay, even in pre-algebra, that's what we did. What do you mean, Thomas? Let's say, for example, if I have 2 over 3, and then I want to have the LCD to be, let's say, 18. What do you multiply here? You multiply by 6. So on the top, you also multiply by 6. Okay, let's say, for example, you have 2 over 3 minus, what is good? 7 over 18. 7 over 18. Then you do the LCD, right? The LCD is 18. Then you need to change the denominator. Therefore, you need to change the numerator also. Right? Do you see the process is similar? Okay, multiply by 6 at the bottom to make it LCD 18. Therefore, on the numerator, I also multiply by 6 to keep that equivalent fraction. Okay, so what we did in pre-algebra, like more than years ago, is still being maintained right now, even when we have expression. Now, the same idea for the second term, the second rational expression. We have 4t on the top, but we multiply the denominator by t minus t plus 3. This is a newcomer. Therefore, that's what I do also. On the top, I will multiply by t plus 3. On the last rational expression, they're the same at the bottom, so on the top should stay the same. The reason we do LCD so that we can put them together under one fraction. Okay. When we say we need to combine like terms, right? Okay, combine like fractions, you need to have LCD first. Once they have LCD, then you can put them together. Okay. If you can distribute right away, go ahead, like what I do here. But if you cannot, you put them together first. I'm missing a T here. Then combine like terms on the top, I get 5t squared plus 9t minus 18 over t plus 3t minus 3. We are not done yet. Try to factor the numerator in case something cancels. Try to factor it. If not, then you just leave it like that. But try to factor it. Okay, I think it is factorable. Minus 3 plus 6 will make it, but I need to change the sign. Negative 15 plus 6 is negative 9. I need plus 9. So change the sign here becomes plus, and this one becomes minus. You see that I can cancel something? Right? I can cancel that t plus 3. So I end up with 5t minus 6 over t minus 3. Okay. That's number 40, number 44. Number 44. 5x over 2x plus 3 minus 6 over 2x squared plus 3x plus 2 over x. I need to factor the denominator so that I know I can see the LCD. Then from there I see, oh, the LCD must contain x, must contain 2x plus 3. The LCD is x times 2x plus 3. Copy paste everywhere on the denominator. Now then do adjustment. I already have 2x plus 3. I multiply the denominator by x. So on the top, I multiply by another x. The second term, already the same, so no adjustment needed. The last one, I multiply by 2x plus 3 on the bottom. I do likewise on the top. Now then, put things together. Once we have LCD, we put things together. Oh. Okay, so the 6 cancels, so 5x squared plus 4x over x times 2x plus 3. But we have common factor on the top. Let's factor 5x plus 4 over x times 2x plus 3. Oh, the x cancels then, so 5x plus 4 over 2x plus 3 will be the final answer for this question. Okay, now on lesson 3, on lesson 3, I will continue from 1.3. So in my lesson 2, when you see the video, I did only half section for 1.3. Okay. So in lesson 4, I'm sorry, in lesson 3, you will see I continue from 1.3, the second half of 1.3. And therefore, I will stop here for this 1.3. Okay. We will continue. We will continue with 1.3b on next section in next session. Okay. Here's the thing though. You need to be really good with this 1.3a first before you go on to 1.3b. Okay. There are so many important material in the second half of this 1.3, and they are things that require at the very beginning of your calculus class later on. Okay, so before I get to that, let me make sure that you watch the lecture video first, lesson 3. Okay, and then try to do some exercise so that you can ask me question on Tuesday. Okay, but at least watch the lecture video. Now, with the time I have left, half an hour, let me go ahead to 2.1. Now, I implicitly have done 2.1 on lesson 1. That is, the topics was on 2.1. The topic was on distance formula. And then midpoint formula. Now, those two formulas are actually quite easy to do. Now, the thing is, in this 2.1, we will put things together and do even more. Okay, and then do even more. Let's take a look. For example, on this 2.1, I think I will do in half an hour. Let's see how much I can do. I will do question number 10, and then number 22, and then number 24, number 28, number 30, and then number 32. 6 questions. I think it should be good enough. Number 10 is easy. That's basically just to review what we did last time. Okay, number 10. Number 10, we have these two coordinates. A to be 2, -5, and B to be 4, 6. First question, find the distance between A and B, the distance between A to B. So distance squared equals to x1 minus x2 being squared plus, I'm sorry, x2 minus x1, and then y2 minus y1 being squared. I will do the square root later on. That's why I write the left-hand side by d squared. This is 6 squared plus 11 squared. D squared is 36 plus 121, which is 157. So the distance is square root of 157. Now, if you can simplify that 157 You should. Okay. Suppose, for example, for illustration, okay, what I mean by simplify. Suppose that's square root of 156 instead. Okay, suppose that's square root of 156 instead, which is a multiple of 4. This is 4 times 39, I think. Okay, so when I say simplify, I need you to write it as 2 square root of 39. When I say simplify, it doesn't mean you change it into decimal and then do rounding. No. That's not simplifying. That's computing or approximating, to be more precise. No. Okay. And in pre-calculus, basically, I don't even need to tell you to simplify. You need to simplify it once you know it's doable. Okay. So yes, that's extra burden on your side, but that's also to train your maturity that we need later on in this pre-calculus course. Okay, why don't we just use calculator terms to compute it? Well, you use calculator, you get the approximation. Okay, but then it is actually not useful in later program. Yes, you still need to write square root of 39, like the one we have earlier, square root of 156. That's square root of 4 times 39, right? So this is actually 2 times square root of 39. Did I write it that way earlier or no? Maybe I forgot, huh? Okay, thank you for reminding me. Okay, but yes, that's how you're supposed to simplify that later. Okay. How about the midpoint? Part B, what is the midpoint? Then the midpoint is equal to the midpoint of the axis and the midpoint of the y's. And use this notation, write this. Don't just give me numbers like, oh, you know what, I do this, and then all of a sudden I get the answer. No, since the beginning, explain your work. So m equals to, that's 1, 1/2. Don't just like this. Oh, you know what, -2 plus 4 equals to 2 divided by 2 equals to 1. -5 plus 6 equals to 1 divided by 2. So the answer is 1, 1/2, like that. No, what are you doing there? Okay, I will penalize you at least 2 points here. 2 points. But why, Thomas? I get the right answer, but you don't show the correct word. What's wrong? What's wrong? Tell me what's wrong. Okay, first one is you don't really explain what you did here. That's one. Okay, and what you did there is actually wrong. What is -2 plus 4? What is -2 plus 4? 2. Oh, hold on. I'm sorry. I'm sorry. Good that you tell me. I keep on thinking our class ends at 11:55. Ah, my bad. Okay, then just cancel this one, 2.1 then. My bad. I'm so sorry. Well, anyway, then on Tuesday next week, then we will do 2.1 and 2.3, and then the second half of 1.3 and 1.4. Okay, well, thank you for reminding me. Okay, let me stop recording then.